pneumothorax. What is the pneumothorax? The numbers are millimeter mercury. After puncture wound in the chest wall, the air can enter to the pleural. It is caused by traumatic pneumothorax. Another is spontaneous pneumothorax, as hole in the lungs cause the air enter the pleural, and to this case cause the collapse lungs. Okay, you can see in these lungs is not normal. This is normal, but is this normal is collapse because the pleural pressure is not negative. Okay. Lung chest interaction. Lungs are suspended within the closed chamber, name is chest. Okay, functional residual capacity (FRC). FRC is the equilibrium volume when the elastic forces of the chest wall and lungs of balance. Okay, changes in the chest volume. The chest volume are responsible for change in the lung volumes. The chest consists of the rib cage and the diaphragm. Because of the natural elastic properties of the chest wall and lungs, the chest wall wants to expand and the lungs wants to contract. Alveolar pressure is the pressure within the lungs. Internal pressure is the pressure between the chest wall and the lungs, and the intrapleural pressure. The pressure within the lungs and chest are small in the magnitude, being measured in the centimeter of the water rather than in millimeter of mercury. It's not different, but is centimeter of the water is better than the millimeter mercury. The pressure difference between atmosphere and alveolar gas results in a lung extension in inspiration, alveolar pressure less than atmosphere, and gas in. Okay, the lung retraction in the expiration, alveolar pressure bigger than atmosphere, and gas out. Okay, gas in, gas out. Mechanism artificial respiration, making pressure difference between the atmosphere and alveolar gas to result in the pulmonary ventilation in the artificial inspiration. Taken together, this figure shows the changes in the lung volumes, alveolar pressure and pleural pressure, and transpulmonar pressure during the normal breathings. During inspiration and expiration, changes in the intrapleural pressure alter alveolar pressures, which generates a pressure gradient leading to airflow and volume changes. The temporal relationship between these various parameters is illustrated in this figure. This relationship between the pleural pressure and the changing lung volume are demonstrated in this figure, showing in the lower panel increasing negativity of the pleural pressure from the -5 to -7 or 0.5 during inspiration, and in the upper panel, okay, in this increase in the lung volume of the 0.5 liter. Then during expiration, the events are essentially reversed. Okay, you can see this is this shows alveolar pressure, this shows pleural pressure. Okay, this is inspiration, this is the expiration, and this is the volume changes in the lungs. Okay, during the inspiration and during the expiration. Okay, and you can see the difference between alveolar pressure and pleural pressure. This shows transpulmonar pressure. In the inspiration is the big, and in the expiration is the low, and was less than the before. Okay, transpulmonar pressure. Alveolar pressure is the air pressure inside the lung alveoli. Okay, when the glottis is open and there is no movement of the air, the pressure is all parts of the respiratory tree are equal to the atmospheric pressure, which is considered to be 0 centimeter of the water, is the reference pressure. we can see important. The pressure difference is very important for the respiration. Your example, you can see the pressure atmosphere, pressure in the alveolar, pressure in this chest wall, and this the difference between pleural pressure atmospheric and pleural pressure alveoli, and this is the pressure intrapleural in this section. And pressure alveolar minus pleural minus pressure in pleural is the shows the transpulmonary pressure. In this cross section, you can see the lines, and this is a visceral parietal, visceral pleural, and parietal pleural in this section, and chest wall in this section. Okay. During the inspiration, pressure in the alveolar pressure to about 1 centimeter water is about, which is the sufficient to move about 5 liters of the air into the lungs within the 2 seconds required for inspiration. During the expiration, opposite changes occur. The alveolar pressure rises to about plus 1 centimeter of the water, which force the 0.5 liters of expired air out of the lungs during the 2 to 3 seconds of the expiration. In expiration, near 2 seconds, and expiration is near 3 seconds. Movement air in and out of the lungs and the pressure that causes it. The pressure pleural and is changed during the respiration. We mentioned before from the -5 to -7, 0.5 is average, and alveolar pressure in the expiration is plus 1 centimeter water, and this is in comparison with the atmosphere pressure 0, and in the alveolar pressure during the expiration is plus 1 centimeter. In this figure, you can see inspiration and expiration from the functional residual capacity. Pleural pressure is negative and is more negative in the during. In the end of the inspiration is more negative, and the expiration, exhalation, okay, inspiration or exhalation is not different between exhalation or expiration. Is the same term. And this is this return to the before. This kind of flow is liter per second in this during the inspiration, and expiration is different. And the alveolar pressure in the negative in the inspiration, and is the positive in the expiration. Okay. This figure as well, the same with before we mentioned before, and is not different. You can see elastic recoil of the lungs, elastic recoils of the chest wall, elastic recoils of the lungs and chest wall in the balance. Okay, this shows in the, for example, elastic recoil of the lungs is the the direction to the enter the lungs, this intrapleural space, for example. And for elastic recoil of the chest wall is is opposite with the elastic recoil of the lungs. Okay, you can see the direction of this is the enter the wall. For the elastic recoil of the chest wall, the direction is the outside. And in this side, you can see elastic recoil of the lungs and chest wall is the balance. For the chest wall and for the lungs, different side, and this is the balance. This cause the lungs will be floated and expand. Functional residual capacity is the equilibrium volumes when the elastic forces of the chest wall and lung at the balance. At the end of the inspiration, and alveolar pressure equal atmospheric pressure, and the airflow stops. At the end of the expiration as well, also alveolar pressure equal with the atmosphere pressure, and airflow with stops. Okay, stops. And this you can see numbers and millimeter and pressure. you can see, for example, the transmolar pressure gradient across the lungs wall equal to intra-alveolar pressure minus intrapleural pressure. This is very important. And the transmolar pressure gradient across the thoracic walls is equal to atmospheric pressure minus intrapleural pressure. Okay, you can see there the pressure in the pleural is negative. Is comparison with the atmospheric and with the alveolar. Okay, this you can see this is lung wall, this the airways, and this here, and pleural cavity greatly exaggerated, and lungs alveolar, for example, and thoracic wall, and this figure shows. Taken together, pressure alveolar minus pressure intrapleural transpulmonary pressure, this is the driving force for lung expansion, okay? And pressure atmosphere minus pressure alveoli is driving force for airflow into and out of the lungs. In aspiration mechanism, we mentioned before, for briefly and for the summary, diaphragm contraction, chest volume is increased, intrapleural pressure decrease, lung expansion. After that, the alveolar pressure, the less than atmospheric pressure, and air is sucked into the lungs. Expiration is reversible in inspiration. Diaphragm relaxation, this causes chest volume decrease, intrapleural increase, lungs, and cause lungs contraction, alveolar pressure more than atmospheric pressure, and air is pushed out of the lungs. Therefore, the expiration is a passive process in the resting conditions. At the end of the expiration, also alveolar pressure equal with atmospheric pressure and airflow stops. In stranger ventilation or active ventilation, masses that chest wall helps produce change in the chest volumes. Behind that, they produce the contraction and relaxation of the diaphragm. Okay, the contraction of the external intercostal muscle helps increase the volume of the chest for a stronger inspiration, while contraction of the internal intercostal muscle helps to decrease chest volumes for stronger expiration.